Good morning, students. My name is Samuel Emeka. In this video, we shall discuss the complex compound units in the United States customary system. Please, the prerequisite for this video is the video on simple compound units. It is highly recommended that you view that video prior to this one. This video is in the playlist, and the playlist is United States Customary System. So the playlist has a series of videos that are numbered in order. It is recommended that you view each of these videos in order so that you can have a better understanding of this. Okay, when we talk of complex compound units, we are looking at two units that they give us two units. Of course, that is a derived unit, like I mentioned earlier in the video on simple compound units. They give us two units and they tell us to convert to two totally different units. I mean, they give us two units and we now have to convert it to two other different units. So there is a method to do it. Okay, let's begin. Convert. Round each answer to the same significant figure as the original quantity. Now, for all the questions that we shall do in this video, we will have to convert, and after converting, we will round our answer to the same significant figure as the original quantity. Question 1. 73.9 pound per square inch to short tons per square feet. So as you can see, the unit they gave us is a pound per square inch, and they want us to convert to short tons per square feet. You know that another name for short ton is net. Okay, another name for short ton is net. N-E-T. So we can do this question two ways, and I'm going to explain the two ways we shall do it. The first way, let's use the method we have been using, called the unity fraction method. Then the second method I will also like to use is the method of proportions. Now, let's start with the unity fraction method for this question. So we have a 73.9 pound all over 1 square inch. Now, why did I write 1 square inch? Because this is a pound per square inch, per. Like if, assuming you go to the store and they say, and you have maybe something like 2 per $5. So this means that $5 will buy 2. Let's say maybe you have 2 pencils for $5 per $5. You know, this sign is what we call per. So that's this sign. It's what we call per. So if you have 2 per $5, that means that $5 will buy 2. Okay? If you have 4 per $10, so that means that $10 will buy 4. Now, assuming you don't that if you have it 2 per $1, okay, that means that $1 will buy 2. Now, if you don't see the 1, it means that 1, okay? Like if I say, can you give me pen? how many pence am I talking about? 1 pen. So if we see something like another example, if we have that Jones is driving at 50 miles per hour, mph, right? We can also write it this way, 50 miles per hour. We can write it this way, okay? 50 miles per hour. Or some folks will write it like this, 50 miles per hour. So this means that Jones drives 50 miles with using a time of 1 hour. That at a time within 1 hour or using a time of 1 hour, Jones drive a distance of 50 miles. So that is what it means. All right. So if we look at the question we are given, 73.9 pounds per square inch. This means that an area of 1 square inch will contain a mass of 73.9 pounds, or a weight of 73. Well, I will say mass in this case, not weight, because weight is in newtons. Now, a mass of 73.9 pounds will cover an area of 1 square inch. So that is what it means. Now, you want to convert this to short tons per square feet. So we can start from the denominator. Now we see this is a fraction. The numerator is 73.9 pounds. The denominator is 1 square inch. So you can start with the denominator to eliminate it, or you can start with the numerator to eliminate it. So if we decide to start with the denominator in this case, this will be 73.9 pounds over 1 square inch times. We want to eliminate the denominator. In this case, we have to eliminate both the numerator and the denominator. Okay, so if we want to start to eliminate the denominator first, we now write square inch here, and we want to now put it per square feet. So we put the square feet here at the denominator. So that later on the square inch will cross out this square inch, and we have only square feet. But we now still have pound per square feet. So in this case, we have to eliminate pound, right? And remember that our pound should now be at the denominator. So we have another one. We multiply now. This pound will now be here, pound, so that pound will cross out the pound. And the short tons will now be at the numerator. Okay? So this is the first thing you do first. That's the first thing you want to do. Then you now ask yourself, what is the relationship between a square inch and square feet? And we see that 1 square feet is 144 square inches. So 1 square feet here, and I put 144 here. Then I ask myself, what is the relationship between short tons and pound? I see that 1 net or 1 short ton is equivalent to 2,000 pounds. So I put 1 here and I put 2,000 here. Then I can go ahead and cross out pound will cross out pound. Square inch will cross out square inch. So at the end of the day, I'm left with short tons per square feet, what I wanted. So this will actually be 73.9 times 144 short tons, all divided by 2,000 square feet. And when you multiply and divide, you have to follow the order of operations. Make sure you follow the order of operations. When you do that, you will now have, and you convert it and you round it up to the original quantity has 3 significant figures. So if you round it up to that, you will have a 5.32 short tons per square feet. And this becomes your answer here. Okay? Now, what if we don't want to start crossing it with the denominator? There is another way we can set it up. We can set it up this way. So we can actually start with the numerator to cross out with the numerator. So I'll have 73.9 pounds all over 1 square inch times, and I want to start to cross out with the numerator. So if I do that, I put pound here, and I'm going to put short tons here. So the pound will be at the denominator, and the short tons will be at the numerator. Then times, I will now deal with the square inch. So I put square inch here to cross out, and I put square feet here. And I put my usual stuff, 1 short ton, 2,000 pounds. And then this is 1 square feet, 144 square inches. I see that square inch, cross out square inch, pound, cross out pound. And I'll still have my 5.32 short tons per square feet. Okay, this is the unity fraction method. What if we want to try it another way? Let's try the method of proportions on the same question. Now, after trying the method of proportion on just this number 1, the rest of the questions we shall use the unity fraction method. Okay? So, if I decide to use a method of proportions, let me just write this out like this: 73.9 pound over 1 square inch, and I want it to be how many short tons over square feet. Now I don't know how many, I'll just have to convert it. So I will do it numerator to numerator, denominator to denominator. Okay, so numerator to numerator, I have pound here, and I have short ton. Let me make a proportion. And the denominator to denominator, let me put a line here. Denominator to denominator, I have square inch here, and I have square feet here. Okay? So, the first line, I will look at their conversion. I see that 2,000 pounds is equivalent to 1 short ton. So I put 2,000 here, and I put 1. Then 73.9 pounds will now be how many? 73.9 pounds. I don't need to write pounds again. Will now be how many? I mean, X. Okay? So I can go ahead and make a proportion from this. Remember, there's 4 ways you can make a proportion. You can say 2,000 over 73.9 equal to 1 over X. Or you can say 73.9 over 2,000 equal to X over 1. Or you can say 2,000 over 1 equal to 73.9 over X. Or you can say 1 over 2,000 equal to X over 73.9. Okay, now, but let me just make it easier for me. I'll just use X over 1 equal to 73.9 over 2,000. So this means that X is what? Because X over 1 means X. 73.9 over 2,000. Now, I don't want to divide it now. okay, so that I don't run into approximation errors. I just leave it like this. I know that this is my short ton. Then I come over here, square inch and square feet. I see that 1 square feet is 144 square inch. So one square inch, let me call it y. Okay, so I have that my y over 1 is equal to 1 over 144. So this implies that my y is equal to 1 over 144. So what I'm going to do is that I will now divide this guy. I'll divide this guy because this is in short ton, and then this is in square feet. This is in short ton, short tons per square feet, and this is in square feet. Okay, so I'll now go ahead and divide it, right? So I will now say that this is now 73.9 over 2000 divided by 1 over 144, right? So, of course, I apply my fraction, 73.9 over 2000 times 144 over 1. And then when you multiply, use your order of operations. When you multiply and divide, you now have 5.32 short tons per square feet. And this becomes your answer. So you can actually use unity fraction method, or you can use method of proportions. Now, for the rest of the questions we shall solve, we shall use unity fraction method. Okay, question 2. 4,870 feet per minute to miles per hour. So we write 4,870 feet all over 1 minute. Then times. Now, minute to hour. Minute to hour. We want to cancel minute. We put minute here, then we put hour. Then times. We want to put our feet here. Feet. And then here, miles. So we look at the relationship. 60 minutes make 1 hour. And 1 mile is equivalent to 5,280 feet. Minute cross out minute, feet cross out feet. So when we multiply and divide and round to the number of significant digits, which is 3 significant digits, we now have 55.3 miles per hour. And that becomes our answer. Question 3. $2.32 per gallon to cents per pint. Okay? $2.32 per gallon to cents per pint. Okay, so we write our $2.32 over 1 gallon, right? Then times. Now, gallon to pints. Do we have any relationship, any direct relationship from a gallon to pints? We do not. So, but who is in the middle? Which guy is in the middle? Quart. Quart is in the middle, right? Quart is in the middle. So we now say, okay, we have to now use quart as the middleman. So we have gallon, then quart, then we now have quarts here, then pints. You know, if you don't have, when you don't have a direct relationship between two units, then you use the intermediate unit. I repeat, when you don't have a direct relationship between two units, then you use the intermediate unit. Then we can now have a dollar here and then cents. Okay, we see that 1 gallon is 4 quarts. 1 quart is 2 pints, and 100 cents is $1. Gallon will cross out gallon, quart will cross out quart, and then dollar will cross out dollar. So we have a 2.32 times 100, which is a 232, divided by 4 times 2, 8. So we have a 29 cents per pint. But they say we should round to the same significant figure. The 2.32 is 3 significant figure. So this will just be 29.0 cents per pint. And this becomes our answer. Question 4. 4.5 short ton per square feet to pound per square inch. So we write a 4.5 short ton all over 1 square feet, 1 square foot. We want to put square feet here, and we want to put square inch. There is a direct relationship, and then there's also a direct relationship between short ton, so we put it here, and pound here. So we see that 1 square feet is 144 square inches, and 1 short ton is 2,000 pounds. Make sure you place the units correctly. Square feet cross out square feet, short ton cross out short ton. So we have 4.5 times 2,000, then we divide it by 144. And that will give us 63 pounds per square inch when we do the necessary rounding. And this becomes our answer. Question 5. 63.8 cubic inches per second to cubic feet per hour. So this is 63.8 cubic inches per second, 1 second, times. Now, second to hour. Do we have a direct relationship between second to hour? No. I know you can say 3,600 seconds is 1 hour, but let's use a middle guy, right? Let's use a middle guy. Let's use a stockbroker. Let's say the company doesn't sell stocks directly, that you have to go through the middle guy, stockbroker, who will eat all your money. Okay, anyway, don't mind me. Okay, so let's use the middle guy. Who is the middle guy here? Minutes. So we put second here, and we put minute here. Then we still have to use this guy, minute here, and hour, so that minute will cross out minutes, second will cross out second. And the last one will now be cubic inch will be here. Do we have a direct relationship between cubic inch and cubic feet? Yes, we do. Okay. So 60 seconds make 1 minute. 60 minutes make 1 hour. And 1 cubic feet is 1,728 cubic inches. Seconds cross out seconds, minute cross out minute, cubic inch cross out cubic inch. So we have cubic feet and hour. So when you multiply and divide, you will have 133 and round. When you multiply, divide and round, you will have 133 cubic feet per hour. And this becomes your answer. Got it? Question 6, last but not the least. 43.8 miles per hour to feet per second. So this is 43.8 miles all over 1 hour. Then we want to convert, do we have straight direct relationship between hour and second? No, let's pass through minute, okay? So we have hour here and minute here. Then we have minute here and then second here. And then we now have, now this means times, I hope you know that. Miles here and feet here. Okay, so 60 minutes is 1 hour, 60 seconds is 1 minute, and 1 mile is 5,280 feet. Hour cross out hour, minute cross out minute, miles cross out miles. When you multiply and divide by 3600 and round, you will get 64.2 feet per second. And this becomes your answer. Now, the unity fraction method, I suggest when you learn the principle, the main thing is to set it up well. Now make sure that before you write the actual numbers, that you set it up well, whereby those you want to eliminate, the units you want to eliminate, you set it up well to be eliminated. And the units you want to convert to, you set it up well to be converted to it. Just take note of that. Okay? Now, no matter how long it is, you can set it up well. Now, let's say that maybe we didn't have a direct relationship between miles and feet. We will still set it up in a way that we can pass through the middle guy. Okay? The main thing there is to set the units up well so that the units can cross out. Then before you now write the actual numbers of conversion. Thank you so much, students, for listening to this video presentation. I hope you enjoyed it. You have a great day.